Hello everyone, this is Madhu Sirikonda, Assistant Professor, Department of Mechanical Engineering, St. Peter's Engineering College. And it is a topic from R&AC subject, Refrigeration and Air Conditioning. We are in last unit and it is heat pumps. What is a heat pump? We all know a heat pump is a device which extracts heat from a lower energy level, say lower temperatures sink. In general we discuss about like sink and source, lower energy level to a higher energy area. We are just pumping the heat, we are extracting heat from one place and we are rejecting, or we are sending the heat, we are transferring heat by different modes to the places where it is required, especially in cold countries. The rooms, their home must be kept at higher temperatures for human comfort. That's why heat pumps are required. By different means, the room will get heated up by different means. You may use different types of stones, or you may use solar energy technology, or you can use this heat pump. Anything, for everything we require a source of heat. Now, what is a heat pump? A heat pump is a device that extracts heat from one place and transfer to another by using mechanical energy. Example, air conditioner or a refrigerator. In that a simple example, we can see that in an air conditioner or a refrigerator, we can see the heat pumps. In modern time, heat pump is an essential part of heating and cooling system. Heat pump is an essential part of heating and a cooling system. If our desired effect is cooling, the refrigeration effect, then it is a refrigerator. If the desired effect is heating, then that will be a heat pump. And the COP can be calculated by desired effect by work input, net work input. Here the desired effect is heating, or the amount of heat rejected, and what we call it as source. Now most of heat pumps are driven by electrical power, natural gas or liquefied petroleum gas LPG can power certain systems that drive an internal combustion engine in place of a conventional electric motor. In the place of a conventional electric motor, you can use any other like a combustion engine. Our intention is to run our system. For that it requires some power, and that power we can get by means of electricity, or it can be by burning a fuel, and you can use a combustion engine. Now, previously we were discussing about the refrigeration systems, compression refrigeration system and absorption type refrigeration system, vapor compression and vapor absorption type system. And in the same way we have the heat pumps, same, that is compression heat pumps and absorption heat pumps. Here the description and explanations figures almost resembles the vapor the refrigeration system, either it can be a vapor absorption or vapor compression system. But the difference between a refrigerator and a heat pump is desired effect. That's it. Here the desired effect is heat rejection. There the desired effect is the cooling effect in refrigeration system. Now the two types of heat pumps, one is compression heat pump, other one is, the second type is absorption heat pumps. Now straightly coming to the description, just observe this figure. In compression heat pumps always operate on mechanical energy, while absorption heat pumps may also run on heat as an energy source. Yes, wherever you in heat pumps you take the heat, there must be a source of heat. That is what he is discussing about. Now absorption heat pumps, an absorption heat pump may be fueled by natural gas or LPG, liquefied petroleum gas. Now see a simple figure on compression and absorption heat pumps cycles. You have, as it is, we discussed about the refrigeration system. Same thing, same components you can observe here. The only thing is the desired effect is heat rejection from the condenser to the place where it is required. Here it is heat distribution and storage system. Now same condenser, you have an expander, evaporator, compressor. Now this compressor is driven by another electrical means, or it is in the case of compression system. If it is an absorption system, in the place of compressor we were having a generator, absorber and a generator, and that is a different story. Now and this is also the same figure. Now coming to the other different types of heat pumps. Water heat pumps. A water heat pump is a variant of the ground heat pump. A ground heat pump, the only difference is that it uses hose on the lake floor or other water source instead of a pipe buried below ground. See here you have, when we go deeper into the soil, the temperature seems to be increasing, and that energy can also be used for as a heating source. Like this, you can see in the figure, it is very clear. Now in the same way, other type of heat pump, it's a rock heat pump. Wherever you find the rock, and there the a rock heat pump is another variant of ground heat pumps, and a very common one. The system uses the solar energy stored in the rock. I said to heat a room, a special type of rocks will be used. They were kept under sun for some time, and those rocks will absorb that heat, and that absorbed heat can be used. We can keep in the cold areas, and that heat will be transferred to the cold areas, and it will give the comfort. In the same way, the absorbed heat from the rocks, that can be used as a heat source, and that will be absorbed by just like a heat exchanger, a type of heat exchanger. From the rock, heat exchange is taking place to the fluid, and that fluid further can be used for different areas wherever it is required. And like that, you have different types. Other type of heat pump here in the ground itself, they are having tubules in a different with a different number of turns, and from one section you send cool water, and after it traveling through a long distance within the soil, and it will get heated up, and that hot water can be used, hot fluid can be used in applications, different applications. How does a heat pump works? We all know that. We know how does a heat pump works. Now let us see the first stage. At the beginning of the cycle, the refrigerant such as freon is in a liquid form, and thus liquid refrigerant is very cool. It enters the evaporator coil. Next, stage 2. After the refrigerant leaves the evaporator coil, it absorbs the heat and becomes a gas. As usual, we have seen this. Now the same, it is like a vapor compression system or vapor absorption system. The same procedure is taking place. Only thing is, either in the it can be a compressor, condenser. Yeah, in condenser, the heat from the refrigerant must be coming out to the atmosphere, the place where it is required. And in the same way, there are the four main components, and as usual we were discussing about evaporator, compressor, condenser and expansion valve. Heat sources and sinks. What's a heat source? Heat source is the generally the bodies with large heat capacities with higher temperature, generally at higher temperature, and the bodies with lower heat capacities with less temperature are called as sinks. High temperature is the source, and lower temperature is the sink. Now, heat pump applications. This is most important thing. Domestic applications, commercial applications, and other things. What's the domestic applications? We can use in our homes, wherever we want to make in cold areas. I said, wherever I want to maintain the temperature for human comfort temperature, we can use for domestic applications to heat the rooms. Heat pumps. We can use heat pumps. Now, many homes can now benefit from a variety of installations, including ground sources most suitable for certain new build properties, and small split or multi-system applied to existing premises. And in commercial applications to, just like a boiler, you can use solar energy technology for heating the water to such a high level, such that we can use it in different, like for in industries we can use that hot water, or in small scale factories, even in our hotels, we can see the water, hot water. They prepare the food and they keep it in hot water to keep the food hot. So such kind of applications will come under commercial applications, and other things are also like in swimming pools, or the places where we require in existing. Let us see this. What is heat pumps are used in many industries to recover heat or as an integral part of the process. Swimming pools can use heat pumps as the primary source of heat for the water in the pool, showers, or to augment an existing fossil fuel system. In enclosed swimming pools, dehumidification is unnecessary, and the heat recovered from the vapor in the air by a dehumidifier is easily returned to heat incoming fresh air or through a heat exchanger. So we can, it's not that only these things are under applications. When you go through the variety different types of videos, you may get what are the different applications. You can go through the textbooks even. You can see the different types of different areas where we apply the heat pumps. You can include them and you can prepare or maintain a notes on this. Thank you.